so we discussed about security problems that can arise because of software bugs, and this could potentially lead to a malicious user getting root privileges on the system, and once the person gets the root privileges, then they can have access to many of the system utilities, system software, and they can change the settings, change the configuration, they can access the files, they can delete the files, format the hard disk, or even encrypt the data so that the user cannot have access to his or her data, and hold user at ransom so that unless the user pays some money, the disk will not be unencrypted. So any malicious activity can be done. The system can be used to launch other attacks on other machines, and or the person can be fabricated, or the user, the genuine user can be fabricated for some crime he or she didn't do. So there are many issues which are related to this kind of attack. So of course, the operating system developers are also aware of these security bugs, and they also try to secure the operating system and trying to limit the access of a user to the things that user doesn't own. So one of the idea was to ensure that any sensitive information can be accessed only through operating system. So operating system will provide system calls, and user has to make call to the system call, respective system call, to access a certain information. And because the system call is written by OS developer, they can actually check what user is trying to read. So through the parameters, they can check whether the user is trying to access an authorized area or not. And that's how the system was controlled. The only problem is that most of the bugs that we are recently discovering and which are creating havoc are basically the bugs which are found in the system utilities or system calls. So if you look at the major breakout recently, you will find that most of them are actually related to some vulnerability which was in a software component which was part of operating system. And naturally, because it was part of operating system, then the user would I shouldn't use the term user. The malware writer would actually get the access to the kernel mode or supervisor mode, and that's why this becomes more dangerous to the user, because user is not aware of the risk that they might that might be there if there is a bug in the operating system. Okay, so we will start with now access control. This is a mechanism which operating system would use to limit the access of the user to the to the resources that they are allowed to use. Okay, so let's go for that. So the basic purpose of the security is to provide isolation between user processes and kernel process. Kernel process is part of your operating system. So basically, operating system security mechanism should be able to isolate one user process from any other process, be it a user process or a kernel process. So what we mean by isolation, what we mean by isolation is that one user process should not be able to affect another user process adversely. So there should not be, so a user process should not be allowed to access the memory which is allocated to another user. It should not be allowed to read or write to that memory which is allocated to other user process, unless there is a shared memory between the two processes. But if there is a shared memory, then the access should be limited only to the shared memory, and access mode should be as decided by the shared memory rules, which are part of the which have been pre-decided between the processes. Then one process should not be able to access resources allotted to another process, not just memory. It could be the devices, it could be the page tables, it could be files, it could be network sockets, it could be any other resource, software or hardware resource, which other process is using right now. And if there is to be allowed any kind of access, then this has to be as per the security mechanism implemented by operating system. So at the same time, the internal data structures of the operating system, what we are calling kernel objects, any unauthorized access to these objects should be prevented, and no user process or unauthorized process should be allowed to modify these objects. I'm not talking of only the user process, even the operating system will consist of many processes. So unless one process which is part of the operating system and does not should not have access to internal data structure, should not be allowed to do that. So there should be a perfect isolation between the processes. And to prevent the unauthorized access to the user needs to be authenticated, as well as the processes need to be authenticated. So generally, user authentication mechanism is done either through something that the individual knows, something that a user knows. Here, user is a person who is logging onto the machine. So a person can hello. A person can access a machine only if he or she knows something, or he or she possesses something which we call a physical token, or something that is the characteristics of the individual. So authentication measures can be based on password or personal identification number, PIN, or some kind of secret answers. Or it could be based on something that they possess. It could be a key, it could be a smart card, it could be a fob, it could be a RFID badge, or it could be some biometric of the person that can be used for authenticating the user. So different mechanisms use different measures. So most commonly used is password. Now the problem in the password is that it is now the onus of the user to ensure that he or she selects a hard password, a password which cannot be guessed by other people. But we all are human beings, and generally we would like to create a password that is easy for us to remember. So most commonly, the people would use passwords which are very simple for them to remember. So generally, it will be like name of their pet. It could be the mobile number, or it could be the mobile number in the reverse order, or it could be the date of birth, or it could be the name of the person, name of their father, mother, something the name of the person that they know, or it could be their own name. So people do use very, very simple passwords, and because they tend to forget it, and or they will keep their passwords in some notebook. And if someone has an access to that notebook or mobile phone where they are writing the password, well, the password is broken. Personal identification number, PIN number, generally they are used in smartphones. They are only 4 digits, so they are about 9,999 combinations. So naturally, in so many attempts, or if the person, if the attacker is lucky, then in very few attempts, this can be broken. So then it could be based on secret answers, but the problem is that even the human beings, they might answer the same question differently at different times. For example, if I ask you what is your favorite food, so right now you might say that this is pasta, but tomorrow you might call it to be a pizza or a burger, or maybe some chapati, dal, idli, dosa. So naturally, the secret answer is dependent upon the time when you answer that question. So after passage of time, we tend to forget what exactly was the secret answer. So the same problem arises. In fact, in case of passwords, people are more, because they're using it more frequently, they are not likely to forget it. But the problem with the password is that for different systems, we have different passwords. So remembering so many passwords can actually create a problem. Yes, we can make use of something physical. We can give something physical object to the user to prove his or her identity. So it could be an identity card. And when we talk about the digital system, so it could be a lock and key arrangement. So you can open the key, then access the system which is inside the room. Or it could be a smart card, which can be used to swipe or which can be used to authenticate you, the one that we are, the kind of the mechanism we are using in our ATM machines. It could be a fob or it could be a RFID badge. The problem with the physical token is that the people can lose them. So now if someone acquires that token, he or she can pose to be the real user. Then yes, we can make use of biometric, but the problem with the biometric is that some of the biometrics change as a person ages. For example, face will change, even retinal scan may change because of some disease. Fingerprint is not likely to change, but over the years, they start, for some people, especially the old people, because it becomes difficult for us to scan their fingerprints. Then there are behavioral biometrics. So physiological biometrics are the ones which are acquired at birth. Behavioral biometrics is that when the people grow, they learn something, and that's how they acquire it. So they acquire during the lifetime, the way people speak, the way they write something, the way they walk. So these can be behavioral biometrics, but they show more variation than the physiological biometrics. So cannot be relied in all the circumstances, but for some systems where the person is so for some system they can be used, but they cannot be 100% relied upon. So passwords are generally the alphanumeric string selected by the user, and most of the and now the point is that this password has to be stored by the system somewhere, so that it can be matched again when the user logs in. The point is that if operating system stores it in clear text, then anyone who has somehow gained access to the system can read the password of other people. So generally this password cannot be stored in clear text, so it has to be encrypted. But then the encryption key has to be also stored somewhere. So generally most of the time the operating system does not store the clear text or encrypted data. Basically they compute the hash of the password and store that hash. So naturally, if a user gives the same text as the actual password, the hash will be same and it will match. It is very unlikely that a different string will hash to the same password. Yes, it can match to the same password. There is no, because ultimately it's a hash. So if the hash is of, let's say, 1 character, then naturally the only possible combination for the hash could be a small 255 combination, sorry, 256 combination. So, and if the number of passwords are 1,000, it means some of the passwords are matching to the same hash value. So main challenge in the password is that most of the users do not tend to use very strong password, because if they use very strong password, then they may not be able to remember it. So this becomes susceptible to dictionary attacks. So in case of a dictionary attack, an attacker will create a list of most commonly used passwords and try to guess the password of a user on the basis of that. It is also, if we are using hash, so the same thing can apply. The attacker can create most common used password and then then compute their hash and try to use this to cause the attack. So this is known as rainbow attack. So one thing is that operating system can try to enforce a hard password. And one thing is that it can ask user to give a longer string. So do not give four characters or 5 characters or 8 characters. Give at least, let's say, 10 characters. But the longer the password, the difficult it becomes user to remember it. Also, operating system can enforce that password should contain a minimum of X number of special characters or so many number of new numbers. So most of the system asks the user to create a password which contains at least one numerical digit and at least one special character. Then operating system can ask user to change the password at specific intervals so that it cannot be So the same password is not being repeated by the because generally most of the users will try to use the same password at other places also. So if somehow they have logged into a malicious website using the same password, then quite possibly the attacker can use that to his advantage. So operating system actually tries to ask the user to change password at frequent interval. Another way of doing it is that even if the user doesn't go for very hard password, if the password is of is not very hard, then operating system can try to harden it by using salt. Salt is basically a pseudo-random sequence of bits which is generated by operating system. And what operating system does is that the user password is concatenated. The string that user types is while giving the password, that string, that clear text is added to the password, and then the hash is computed. And this will ensure that the hash will be different for two users who are giving the same password, because the sort will not be the same for both the users. So even if let's say both the users are giving a password as ABC123, so even then the hash value for both the user would be different. So it becomes difficult for the attacker to know how the password is stored, because now it is not just a hash of ABC123, it is hash of ABC123 plus some salt. And now user can use same password on different system, because ultimately in the system, the hash value will be different. So it actually increases complexity for launching an attack. So this is how the password with salt will work. So basically password file will consist of the login ID of the user. It will consist of a salt, and it will consist of the hash code. So when the user gives a password, the salt and password are used as an input to the hash function, and this value is actually so this value is actually stored here as a hash code initially when the user gives the. Now when the user gives so initially when the user gives the password for the first time, salt is generated, password is and salt are fed as an input to the hash function. The output is obtained, and this output should be stored as a hash code. Next time when the user gives the password, again the salt from the password file and the password which the user supplies are given as an input to the hash function. The output is compared with whatever is stored as the hash code, and if they match, the user is allowed access. Otherwise, the user is not allowed access. So tokens can also be used. They are possession based, and some of them can be easily copied and clones can be created. For example, magnetic card. Some of them are difficult nowadays. A smart chip card, they are difficult to clone because they contain a cryptographic processor. Physiological biometrics have the possibility have the following problems. One thing is deployment and the complexity of the physiological biometric. For example, if you're using speech as a biometric, then the person is required to say something. And and because a person can speak the same thing again and again differently, she may have sore throat or may not be feeling well. So speech may be affected by that. So to ensure that the user is not denied access because of these variations, so you may have to collect many speech samples at different times so as to ensure that the user can go through. The problem with the system would be that it will not it cannot be generalized to any word which is spoken by the user. It may be specific to certain words only. Then it will require some time for processing this data. It will be much more than requiring a numerical comparison, which is required in case of password or string comparison. So it will be taking more time in authenticating the access. Then it should be acceptable to the user. Most of the people may not be happy with giving their biometric, or they might not be happy with their eyes being scanned. And then there are privacy issues with collecting biometric, because user doesn't know where this biometric is being stored. Then irrespective of how good a biometric could be, the system that you design will always be suffering from some false positive and false negative. So what we mean by false positive is that unauthorized user is recognized as a correct user, genuine user, or authorized user may be denied access. So depending upon the application, in some application, false positive are not at all acceptable. For example, military applications. You do not want any unauthorized person to be recognized as a genuine user and gain access to the facilities. Similarly, the false negative can be annoying, and it can result in the loss of credibility of the authentication system. So implementing biometric as a mechanism may or may not be always very, may not be a good idea at all places. So one of the way that operating system in secure environment tries to implement security is through two-factor authentication. This is a most common authentication mechanism which is used in online banking or financial services nowadays. So the idea is that two different channels will be used to assess whether the person who is trying to gain access to the system is a genuine person or not. So the idea is that one way is that all of you have used this two-factor authentication. Some of you use it in for Gmail accounts or your email accounts also. So the idea is that when you log in, the system will send a SMS or a PIN number or a code to your registered user, registered mobile number. So only when you enter that mobile, whatever you receive on that mobile, you'll be allowed access to the system. So the idea is that a person may, the password of a person may be revealed to another person, maybe the friend, or maybe let's say someone who knows you very, or someone has just guessed it correctly. But the person may not be having your mobile phone in possession. So he or she may not be able to gain access to the code which was sent on the mobile. So this two-layer of security cannot be easily passed by an imposter. So that is the idea. So similarly, if you look at Icici Net Banking, they actually give you a debit card. On the back of the debit card, there is a grid, and on that grid, some characters, and corresponding to characters, some numbers are printed. So whenever it wants to authenticate a person, it will select some random characters from that grid and will ask you to enter the corresponding numbers. So what is the corresponding number of A? What is the corresponding number of G? What is the corresponding number of N, etc. So these two way of two-factor authentication increases the decreases the probability of an attacker gaining access to the system. So this is what we were trying to say, is that gaining access to the physical machine, but within the operating system, the access to the resources such as files or software which a user can run, or gain access to the device drivers, can gain access to the hardware through device drivers, is restricted through access control mechanism. So basically access control is a general term, and we will see how operating system implements access control in reality. So an access control is a security policy that specifies what type of access is allowed to a user on a given object and under what conditions. So naturally, to ensure that the policy is correctly implemented, an implementation will require some kind of information that has to be stored, and this information should store what are the different objects in the system, what are the different subjects in the system, what access is allowed to which subject on which object and under what condition. So this is a kind of, you need to create the operating system needs to create a database. This database will consist of subjects, objects, and the access allowed to each subject on a given object. And the way this database would be implemented will vary from operating system to operating system. To ensure that a security audit can be done to see that nothing has gone wrong, most of the operating system will log each operation. So whenever a user logs in, it will write into a log file. So any activity which is created by a user while entering the system, exiting the system, or trying to access any resource on the system, it will be logged in. And through this log, the security audit software can check whether that every access was as per the security policy. And if there is a violation of the security policy, then the same can be, an alert can be raised to the system administrator, and they can take appropriate action. So generally, the security policy will follow principle of least privilege and principle of attenuation of privileges. So principle of least privilege say that do not give a user more rights than required. So if I need to read a file, then I should be only allowed to read the file. I should not gain access more than reading the file. So minimum privilege means, least privilege means that whatever is the least privilege level that can be associated with that operation should be allowed to the user. User should not be allowed more privilege than is required to carry out an operation. So even if a user is allowed to complete an operation, so he or she should not be allowed more than that. And principle of attenuation of privilege says that once a privilege has been granted to a process cannot increase that privilege by itself, or it cannot transfer the privilege to another process if it doesn't have right to transfer. So whatever privilege has been granted, the process will continue to run with that privilege unless that privilege is modified by the operating system. So generally, when we are talking about the subject, we are talking about, in case of operating system, a subject will be a user or a process. Now, an object. So this is an entity which is requesting access to certain object. Object is a resource to which access will be required. And now it can consist, again, it could consist of some application or process. It could consist of hardware devices or software processes which are running on the system. So there are many things which can qualify as an object. And now access would be consisting of whether a subject can read an object, or it can write to an object, or if it is a process or application, can a subject execute this process? And then there could be other, so can it execute certain function in that software object? Now, access control system can be mandatory access control. It could be discretionary access control, or it could be role-based access control. What we mean by mandatory access control? The mandatory access control is that in this particular case, the access control mechanism has predefined security clearances, and access is granting on so every resource is given a security label, and every subject is given a security clearance. So unless the security clearance of a subject is greater than or equal to security label of a resource, the access is not allowed. Similarly, subject with the requisite, a subject is not allowed to transfer its clearance, its security clearance to other subject. So naturally, if someone is trying to access a resource with a certain security clearance, that will be locked. So even if I give my password to some other person, I'll be held responsible for whatever is being accessed by that person using my password. So if I have a security clearance for certain document, and whenever that document is accessed with my security clearance, I will be held responsible. I'll be held responsible. So generally it is used in military or defense mechanisms, or research, which is, or very, very, even in industrial environment where they are trying to develop a new product, or researching on something, on cutting edge technology. So they wouldn't like other people to know about what is being done in the research and what are the outcomes. So this mandatory access control will be used for sensitive application. So even the physical access and access to the data, access to the equipment will be governed by these this access control mechanism. Another one is discretionary access control, in which there are certain authorization rule and access will be granted to a subject based on his or her identity, and subject can delegate the privileges that it acquires to other entities also. So role-based access control means a user can assume different roles, and the access which the user can have in a particular role will be defined by that role. For example, if I'm trying to log into ERP system, I can log in as a professor of the department, or I can log in as the course coordinator. So let's say I've got two different roles, or rather I should specify, like, let's say there are two different roles assigned to a faculty as a coordinator of a subject, or faculty as a DUGC, or faculty as a head of department. So naturally, these are three different roles, and three different roles, the functionality which ERP exposes to that person is as per that role, and the activities that can be carried out by that person will be as per roles. So the privileges which a person acquires as a role are limited to that role, and the functions which are available available to that person in that role. Now, what could be the access rights? If we're talking about a process, then a person can launch a process, a person can delete a process, it can stop that process from running or kill the process, or it can wake up a sleeping process. If you're talking about the access rights to the device, a person can read from a device or write the device, or person can block that device from use or unblock that device from use, and it can control some operation of the device, like formatting the device, or making the device sleep, or asking some information or give some command to that device for some purpose. If you're talking about the memory location, it means you can read from a location, you can write to that location. And if you're talking about user, so if a user A has some access right on user B, what it means is that user A can sanction some privileges to user B. It can transfer, grant some rights to user B, or it can revoke rights from user B. So generally, the security policy would be represented in terms of an access control matrix, where the columns indicate the objects and row indicate the subjects or the user. Subjects, as I said, could be a user or a process. So when I say user, it actually includes processes also. So every cell will now record the rights of a user in respect of that object. So for example, user one can be the owner of the file. It can read from the file, it can write to the file, but he or she has no access on file 2. On file 3 it can only read. On directory 1 it has no access, whereas user 2 can read from file 1, it can read and write from file 2, and it is the owner of the directory 1, etc. But in this directory 1 it can read as well as search, and user 2 has not granted any access to directory 1 to user 1. So this access control matrix will contain all the information. But the problem would be implementing the access control matrix could be problematic, because this matrix can become very, very large, and most of the entries in this matrix will not be useful. They will be actually null, or they will not be any entries. So this becomes a very large matrix, So most of the operating system do not store access control matrix as such. So they either go for access control list, or they either go for access control, or they go for capability list. So we'll come to it later on. So when we talk about A is the access control mechanism, control matrix. The row is indicating the subject and column is indicating the objects. So ASO actually represents a certain entry for subject S on object O. Now the primitive operations would be creating new subject, that is adding a new row, creating new object, adding new column. Sometimes creating new subject would actually mean adding a row as well as a column, because subject may be used as an object by other subjects. So just we need to remember. So if a new process is created, other processes may or may have some right on that process. So creating a new process would actually mean adding a new row as well as adding a new column also. So it depends upon the kind of the subject that you are creating. Similarly, destroying a subject, it doesn't mean destroy. For example, a user logs in and logs out. So that user is no longer in the system. So the corresponding row for that user may be deleted. Similarly, so again, if while creating the subject, we added a row as well as a column. So while the subject leaves, or subject is destroyed, or subject is killed, or subject exits, that corresponding row will be deleted. And if there was a column which was created for that subject, that would also be deleted. So when an object is deleted, then the corresponding column would be deleted. Then if you are entering a right, so if a particular right is allowed, particular privilege is allowed, particular access is granted, then there will be a modification to this respective cell. Again, deleting the right will also make modification to this cell. And then operating system has to have some kind of software mechanism that will check. So whenever whenever a subject S tries to access object O, it will check that this access is as per the entry in this cell. So these are the access control operations can be formalized in this following manner. So if you are creating a new subject S dash, it is equivalent to adding a new row. So S is the so first of all, we are adding this new subject to the set of subjects, and then we are going to create a new row for the subject, but all the entries will be initially set to null. And as I said, that when you're creating a subject, you're also adding the column corresponding to that subject. So a row is added as well as a column is added. And for this new row and this new column, initially the entries are 0. So whenever a subject is created, it's added to the list of subjects as well as the list of objects. Now, when you create an object, it will be added only to the list of objects. And new matrix will contain a new column, and this new column will be set to null. Similarly, destroying will remove object, will remove a corresponding column. And if you enter a write into ASO, the corresponding write will be added to the respective entry. And similarly, a write will be deleted. What it means is that all other entries where the subject is not equal to the subject S, the entries will remain same. Only for the entry will be modified only for this subject. So when a process is creating a file, an object F is created, and because this process has created the file, this process is owner of the file, and it will have read and write both writes into the it can read from the file, it can write to the file. So the rights owner, read and write will be entered to the corresponding access control matrix for this process P for this object file. Now, when a process confers read writes on file F to process Q, it means for the entry in access control matrix for the process Q and file F, we will enter R. R means read. If the process revokes the read write from the file, then this entry will be deleted. So sometimes the rights, a process can assign rights to another process Q, and these rights can be delegated by process Q to yet another process. So means when a process assigns a right to process another process, and it also allows it to transfer those rights, then the situation will become slightly more involved, and revoking the right will ensure. So when process P revokes the right from process Q, ultimately it also should mean that any right which process Q has passed on to other processes may or may not be revoked depending upon the security policy. Okay. So R star means rights which are allowed to so the process can transfer the rights to other process. So now access control mechanism. So let's say we have implemented some security mechanism, and S is the set of all possible states, and P is the set of states authorized by the protection. So and R is the set of states reachable with the security mechanism. So what we are trying to say is that S is the set of all possible states of the system, and P is the set of the states that a particular user is allowed to be in. It cannot be any other state other than P. But somehow the way we have implemented the security mechanism, the user can only be in R state. So here P is also a subset of S, and R is also a subset of S. So as long as the set of the states which are allowed by our implementation of the security mechanism is a subset of P, which P is theoretically speaking, this was the set of the states the user was allowed to be in. And R is the set of states which the user is allowed to be in by the security mechanism. So as long as R is a set of P, R is a subset of P, it is secure. And as long as R is equal to P, the system is precise. And if a system is secure but not precise, then we are trying to overprotect. We are trying to be over restrictive. We are not allowing the user to be in state which he or she could have been as per our theoretical model, but we are trying to restrict access to some of the states which were theoretically allowed. So otherwise, if R contains some states which was not part of P, it means the system is insecure. So this is how the access control mechanism terminology will be talking about the secure, insecure, precise, and overprotective systems. So, for example, in most of the systems, your BIOS allows you certain functionality on device hardware, such as you can read data from hard disk, you can read data from keyboard, you can read or write data to certain output device. So there are some interrupts which are support with the interrupt handler for them are actually coded in the BIOS. Now, to most of the modern operating system do not permit it, but earlier people could directly use those BIOS interrupts to gain access to the hardware device. Or you can use system calls of the operating system to gain access to the hardware device. Now, operating system may or may not make use of those BIOS calls because now for a programmer, if the programmer is using a system call of the operating system, then even if the operating system gets updated or BIOS gets changed, the program will still remain functional. But if someone is making use of BIOS calls, then this may work only on the devices which are supported by that BIOS. And if the BIOS gets updated, this may or may not work depending upon the whether the compatibility of that interrupt mechanism is retained or not. But the point is that if someone is making call to a BIOS interrupt and not to the operating system call, then the person can still attain the same functionality and bypass the system. So this could create a insecure channel. So person can directly read data from the hard disk without operating system being aware of it. So when you're making call to a disk controller through operating system can check that you are not trying to read data or write data to a block which you are not authorized to do it. But by using disk interrupts, a person can gain access to the hard disk, complete hard disk. Now the point is that most of the system, should we allow sharing between the processes or not? Well, if you do not provide sharing, then yes, there are some limitations which can occur. For example, in most of your smartphones, different apps interact with each other to make your handling of the system become easier. For example, you can upload data from your PDF reader to your email system, or you can share some file through WhatsApp, and then you can share the same file through using some other mechanism. So there are your many of the some of the apps, they are using Google Maps or other maps to provide you information about your current location. So there are sharing of the data between different processes, and but when we are sharing the data, can we trust the subject? Are they going to leak this copy to some other object or not? Yes, this has become a very big concern, especially in mobile operating systems, where the different apps are gaining information from the user, keeping it in their private stores, or so we do not know what happens to that information, whether this information is being covertly leaked by these apps to other apps, or they are being leaked directly to the internet and stored somewhere remotely. We are not aware of that. So security mechanisms needs to check for such data filtration. Now the problem is some of this data filtration may be disguised as data being transferred during the update mechanism, and can be sent to the remote systems in an encrypted way. So it becomes difficult for us to trace this data, where this data is being actually leaked to. Then another problem is that when we are sharing the data object, then there might be multiple copies of the same object. So consistency maintaining consistency would be a problem. Sharing of program can be even more problematic, and so sharing has its own disadvantages, and it has to be done with care. So we'll start from here in the next class, when we are going to discuss about different problems. One of the problem that we are going to discuss is confinement problems. So we'll start from here in the next class. I'll share the slides with you after the next class, or maybe I'll share it today. Well, let me see. So if there are any questions, you can ask me. Let me go to chat. So if there are any questions. Let me just pose quickly the question for the attendance. So please answer that. So please answer the question on classwork and we'll call it a day.